Welcome to section 11, Relational Databases. Go language can work with various relational databases that includes SQL Server, MySQL, PostgreSQL, and SQLite, and so on. In our examples, for simplicity, we are going to use SQLite. SQLite might be a little more limited compared to other more advanced database engines, but for our examples, it is pretty much sufficient. Okay, let's start with reading data from SQL database. I have already created a database called PersonalDB. I'm using this tool, which is DB browser for SQLite, that allows me to create new SQLite databases and edit them, add new records, and so on. You can find more information about that tool and you can download it from this location, sqlitebrowser.org. It is a free tool and it works with Windows, Mac, and Linux. All right. Let's dig into our example. So here we have just one table, and that is called profile. And working on this table will be enough for us to learn how to interact with a SQLite database. And therefore, you can use the same techniques to interact with MySQL or SQL Server as long as Go has a driver for it. So here in our profile, we have 3 records, 4 columns: profile ID, first name, last name, and age. These first name and last name columns are string, or in this case they are text, and the age is a number, and the profile ID is our primary key, and it also is an integer column. So it is pretty much straightforward. There's no complexity here. So let's go ahead and create our own struct. I'm going to use that struct type to map data that come from a SQL database to our in-memory objects. So I'm just going to type it in. I'm going to call it profile, and that's going to be a struct. I need to import 2 packages. The first one is database SQL, so let's import them. And the second one is this one. I'm going to do a empty or blank import by doing this, but when I do this, the ID I'm using will automatically remove the database SQL import, but that's alright since we're gonna import it back when we start using it. And the reason why we are doing here a blank import is that if there's an initialization code in this package, it will still be executed. This package registers itself as the underlying SQL driver. So we still be using database/SQL package as our API, but that API will be using this package behind the scenes to interact with our database. And as you will see, the database interaction in Go is pretty straightforward. So the first thing I'm going to do is to open the database. So when I use the SQL package, you see that it automatically imported our database.sql here. And I'm saying I want to use SQLite driver, which is SQLite version number 3. And you also specify where your database is located. And this data source name may change based on what type of database you are using. It might be an URL. In our case, it's a file since SQLite works with data files. So I'm going to say PersonalDB. I also added this check error utility function, so I don't have to keep checking the error all the time. What I'm going to do, I'm just going to say check error here, and it will check the error. So here I'm going to specify our variable for profile. And now we're going to use db.query to query our database, and that returns 2 things. One of them is rows and the other one is error. So here I'm saying database query, and it basically accepts a SQL query here. Again, we say check error to check the error here. And now I'm going to use a for loop to say next to iterate each row, and we will use rows.scan to scan each row and get the value out of each row. At this point, I'm using the address of our profile fields because it expects us to send a pointer type so that it can fill that type and you can use it after it's filled. I'm going to keep saying the rest of it. It is important to respect the order of your columns as they come from the profile database. If you need different order, you can specify here. I usually recommend to explicitly specify each of the rows here instead of using this all sign. So such as, that will be more predictable going forward. I'm just gonna print this to our console. And each time this iteration works, it will fill our profile variable and we're going to print it out to the console. The last 2 things is to close the row and database so that we don't leak any resources. Let's go ahead and run this now. Perfect. As you see, we were able to capture our database records. And this is the profile ID, and this is the first name, last name, and age. And we capture it for all of the records here. Okay, let's quickly look at how we can do filtering here. So I'm going to use where clause, and if you know SQL, where clause is used for filtering. And let's go ahead and filter by profile ID, and I'm going to say question mark here, and that will be our placeholder. And if you look at the signature of this query, the second parameter is arguments for this placeholders, and since it is a variadic function, you can provide as many arguments as possible as long as you have a matching placeholder here. So what I'm gonna say is 2. You can also use a variable name here. So let's go ahead and run this. Okay, so we got our record from database. You can also do multiple where clauses here. So I'm gonna say first name is this question mark and last name is this question mark. So here I'm gonna provide 2 arguments. The first one will be Tariq and the second one will be this. I think it looks good. Okay, let's go ahead and run this now. Perfect. It is the record I was expecting. All right, that's how you can easily query a SQL database in Go language.